you understand what I just said? What did I say? I know, what does that mean? What is it? Trinomial is what? Three what? Terms. Three different terms of degree 2, single variable. What does that mean? Squared. Okay, so it's something squared. What does that graph, if you were to graph something that has an x squared, what will it graph to be? Yeah, some of you are showing me correctly. What is it? A parabola, right? A parabola. It looks kind of like a UV type thing, right? Kind of a U-ish V thing. Everybody got it? Okay. How many times will that cross the x-axis at most? Twice at most. When you solve those equations, what are you finding? You're finding the values of x, right? But what are you actually finding? The points where it crosses the x-axis. Now yesterday, we had something like this, right? And all we were doing was trying to figure out how to expand it. So how do I expand that? Go ahead. How do I square that out?
You do x squared.
Yep. What'd she do? First term what? Squared. Then what? We'll go next one. What's the next term going to be?
Still me.
Uh-huh.
Then it will be 6x squared.
Negative or positive?
Wouldn't that be positive?
Positive times a negative is a negative 6x, because it's 3 times negative, excuse me, x times negative 3 is negative 3x, doubled, negative 6x, right? Then the last term is going to be what? Negative 3 squared is? Plus 9. That's what we did yesterday, right? Okay. This will graph to be a what? A parabola. Let's do it old school longhand way. You guys remember how to do old school longhand? What's old school longhand? T-chart. T-chart. Very good. Okay, this is called f of x. And so these are the y values, if you'll think of it that way, or the f of x values. Okay, and these are the x values. We're going to plug in x's, we're going to get some y's. I should put that on the opposite side. It'll just look better. X, y's, right? F of x. Alphabetical order. It'll be better. Okay, let's just pick some values. Let's pick 0. How about 0? Is everybody good with 0? How come 0? Because 0 is super easy to plug in. What do you get for y? 9. Negative, or positive 9, right? Okay. Positive 9. How about 1? Do the math. 1 squared 1 minus 6. 1 minus 6 is negative 5. Plus 9 is 4. How about negative 1? Negative 1 squared. No, it's not. Negative 1 squared is 1. Negative 1 times negative 6 is a positive 6. So it's going to be 15, right? Is that right? No, 14. My bad. No, 16. My bad. Sorry, 16. Yep. Negative 1, 16. Then 1, 4. Then 0, 9. Wow, that's interesting. So think about what I'm graphing here. Negative 1, 16. We'll call that 16. And then I'm 0, what? 9. And then I'm 1, what? 4. What's your guess on 2 without even plugging it in? Do you see it? Do you see the pattern? Perfect square, perfect square, perfect square. Oh. What's the next one going to be? It's going to be 1. I'll plug it in just to show you, but it'll be 1. 2 squared? What's 2 squared? 4. 2 times negative 6? Negative 12. 6, or negative 12 plus 4 is? Negative 8 plus 9 is? 1. What do you think the next one's going to be? What do you think 3 is going to be? How do you know it's going to be 0? Go back up to the original. What's 3 minus 3?
0.
The 0. So it's going to be 0. Even if I put it in here, will it still be 0?
Yeah.
Yeah, 3 squared is what?
9.
9. 3 times 6 is negative 18. So I got 9 and 9 is 18 minus 18, 0, right? Okay, so we have 2, 1, 3, 0. Now, what do you think 4 is going to be? 1. Say, oh. Okay, don't say it. Oh. Oh. This is 1. What do you think this is going to be? 5.
4.
4. What do we call this? Not just this. What do we call it when the left mirrors the right? Symmetrical. Remember in math, we talked about Pascal's triangle, right? Math things, for some reason, I don't know why, we like symmetrical things. Symmetrical objects, symmetrical pictures, symmetrical numbers. Anything symmetrical, it really goes well in math. And that's what this creates. Parabolas create symmetry along this line of symmetry, right? This line of symmetry. If I took a piece of paper and folded it, that graph would fold right onto this graph. The tracing of it would. You with me on that? Okay, so that's just kind of cool, right? That's the only 0. Is that true? But it's a square. How many zeros did you expect? How many at most could you have? 2. You said that at the first of class. You said I could have 2 zeros, but this one only has what? 1. Why? It was only 1 quantity squared, so there's only going to be 1 what? 0. In fact, this is duplicity. It hits 3 on the way down and on the way up. It's duplicity because what does this really mean? What does x minus 3 squared mean?
X minus 3 times x minus 3.
Yes. Watch. If I set this equal to 0, by the way, what do we call these? What do you call this point right here that touches the x-axis?
The x-intercept.
X-intercept. Some people call it that, and that's correct. What else do we call it? We also call it the 0 of the function. Because what is the y value of the function? Remember, the y value is of the function. What is the y value at 3? At 3, what's the y value?
0.
0. So anytime it crosses the x-axis, we call it a 0. Guess what else we call it? It's the solution. Because if I set the equation equal to 0 and solve it, this is the solution. Now, I got another question. Okay, here's my equation. What's your name? What? Sabrina. Sabrina. If a times b equals 0, tell me something about a or b.
It's going to be 0.
One of them has to be what?
0.
0. Everybody agree with that? Either a is 0 or b is 0. How come? Because if a times b is 0, the only way you're going to get things timesing to be 0 is to multiply by what? 0. So by the way, let this be a and this be b. If a times b is 0, either a is 0 or what? B is 0. But those two are exactly what? They're exactly the same. Now, solve that equation. Can you do that? X minus 3 equals 0. This is really hard. How are you going to get the x by itself? What are you going to do?
That's 3.
Add 3. Yeah, this is like really easy. So I just add 3. What do I get? X is 3. What will this one be? Exactly the same. That's why I call it duplicity, because it has 2 factors, but they're exactly the same answer. It's 3 on the way down and on the way up. Kind of cool, huh? Okay, now. Tell me the factors of this parabola. Think about what we just did. We did x minus 3. It crossed out 3 plus 3, even though it was minus in the factor. Tell me the factors of this. First of all right, apparently I blew your mind right there, so calm down. Let's slow down a little bit and just say, what are the zeros of this function? Can you tell me that at least? What's your name? Yeah. Addison. What are the zeros of this function?
-2 and 4.
-2 and 4. Very good. Woohoo for Addison. Let's.
Her name's Aspen.
Aspen, whatever. All right. All right. So that's the zeros. I'm asking you to write those zeros as factors. Can you write the zeros as factors? Riddick, is that right? Riddick. What do you think they are? Oh, come on, Alex. What do we got?
I think it's x plus 2 times x minus 4.
It is x plus 2 times x minus 4. Could I multiply those out, get a quadratic, punch it into my calculator, and have a graph? I could do that on a graphing calculator. Huh?
You switch them?
You do switch them. Why? Why? Because x equals -2. But I want it to be equal to what? 0. So how would I get this to be true? To get it equal to 0? Add 2. So x plus 2 is what? Is a 0. X plus 2 is a 0. It will happen at -2. X will be -2. But that's where it's zeroing out. Can you see that now? So if I took this one times this one, if this is 0 and this is the 0, yeah, that's going to work. Because this is at 4, again, if I have x equals 4, what would I do to set it equal to 0? Subtract 4. So that's why it's just the opposite. Can you see why it's the opposite now? Okay. So that's kind of cool, right? That's kind of neat. All right. So we multiplied these, but today we're just going to solve these, and they're super easy, actually. So this is going to be a pretty easy assignment on what we're doing today. So all we're going to be doing is solving them. Now, sometimes you'll have to factor them. Now, we're going to do, I think, just basic factoring. Turn to, oh, you can't push pause. Okay, turn to 2.4. Turn to 2.4 in your book. And you're going to do, let's see here. You're going to do 4 through 36, 4K plus 1, and 39 and 40.
Okay.
Did you get that?
4 through what?
You're going to do 4 through 36, 4K plus 1, and 39 and 40. Okay? I'm going to do the following with you, just so I can do one from each section with you. 8, 16, 24, 29. Kind of write these down, the ones that I'm saying. And 36. Okay? Those are the ones I'm going to do with you. Okay, somebody read me the first one because you're embarrassingly easy and they go really fast. Give me the first one.
It's 8.
8, read it.
Y plus 2 times y minus 6 equals 0.
What do I know about one of these two factors?
One of them 0.
One of them 0. So either y plus 2 equals 0 or y minus 6 equals 0. Solve those. What do you get? -2 and 6. Now in my other class, I always make them, subtract, add. I figure you guys are advanced enough you don't have to, show all that work. But do show this. Why do I want you to show that so bad? Because it shows understanding of the problem. It shows that when I multiply two things and it equals 0, one of them has to be what? 0. It shows understanding of the problem. So I want you to at least set that up. Is that very hard?
No.
No, it's like super easy. So those first ones are super easy. What's the next one I asked to do with you?
16.
It's still just as easy. What does 16 say? Parenthesis what? Let me read it.
No, it's 5p.
Oh, 5p out front, okay.
Times 2p minus 3 times p plus 7 equals 0.
Okay, this one's a little bit different because of that 5p, right? But is it really that different? How many products do I have? How many things are being multiplied together inside the parentheses? This is a binomial being multiplied to another what? Binomial being multiplied to a, what's this called? This is a monomial. Because there's no plus in there, right? So a monomial to a binomial to a binomial. Multiplying all three together. There's 3 factors. That's what we call them. This is a factor, this is a factor, this is a factor. In other words, it crosses this axis how many times? Remember, this is y-axis right there. How many times will this cross? 1, 2, what? 3. This is going to cross it 3 times. If I multiplied that out, it would be p to the what power? What would be the degree of the polynomial? Think about multiplying that out, all the way out.
2.
P to the what?
3.
Third. P squared, and then times another p will be p to the what? Third. If it's to the third power, guess how many possible zeros there are? 3. If it's to the second power, how many possible zeros are there? 2. Now that doesn't mean that sometimes they repeat themselves, right? Or sometimes it never gets there. We'll talk about those later. But for this one, I just want to set each factor equal to what? 0. Is 5p a factor? Yes. By the way, the word factor means what? You might want to write this in your notes. What do you think the word factor means? It's something that is going to be multiplied to something else. It's a multiple. So a factor is just a multiple.